Okay, moving on to things that are a little more complicated. When, well, I guess just take a look at this example down here, where you've got y equals the natural log of this quotient of things, x squared plus 3 over the square root of 4x minus 2. Now, when you can use your log laws or your log properties to expand before you differentiate, you should do that. Okay, so to differentiate something like this, just thinking about our rule, we'd have to do 1 over all of this stuff, if this is u. And then to find u prime, we'd have to differentiate this stuff here. That's going to need the quotient rule, it's going to need the chain rule, and that's more complicated than it needs to be. Okay, so big thing here is if you can use the log laws, to expand before differentiating or before finding the derivative, then you should 100% of the time. If you can use the log laws to expand fully before differentiating, then you should. Here's just a really brief review of what the log laws are. So in the first law, if you have the product of two things inside of the natural log, you can split this up into the sum of the individual natural logs of the factors. If you have a quotient, you can split this up into the difference of the two individual natural logs, where the numerator comes first. If you have the natural log of a power, then you can rewrite this so that the thing inside the natural log is just the base that was raised to the power, but then you multiply by the power on the outside. Okay, so let's look at this example down here and first expand all the way and then take the derivative. Okay, so the first thing I want to do here is expand. Now we have a quotient here, and if you remember the little kind of tricks that I told you about in the review section for logarithmics, we want to look at what's multiplied up top and what's multiplied down bottom. So up top we have just one factor that's multiplied. Down bottom we have just one factor. So we can split this up into two natural logs, because we've got two things total, and the top will have a plus in the front and the bottom will have a minus in the front. So this will just be y equals the natural log of x squared plus 3 minus the natural log of the square root of 4x minus 2. And then once you do that, the only thing you need to check for is if there are any exponents. Now I know in the first natural log here, we do have an exponent of 2, but everything in the natural log needs to have the power on it. So it's not like this is x plus 3 squared. In that case, we could bring the 2 down. But this is not just like a big thing raised to the second. So this one is actually expanded as far as we can get. This one here, though, has an exponent of 1/2 on it. So we can simplify that one by bringing the 1/2 down as a constant multiple. Now we've expanded all the way, so now is a good time to differentiate. All right, so we've got basically two parts to find the derivative of, but they are simpler now, right? So we're just going to differentiate each of them separately. So we've got natural log of x squared plus 3. Okay, so here the u is x squared plus 3, and u prime then is going to be 2x. So when we find the derivative of that first piece, we'll have u prime over u. So that'll be 2x over x squared plus 3. There's the derivative of the first natural log. In the second natural log, we have a 1/2 in the front. Okay, that is a constant multiple. So what happens to constant multiples when we differentiate? Well, they constantly multiply. They stay there, and they're going to multiply by the derivative of the natural log of 4x minus 2. So here we've got a separate u. That's going to be 4x minus 2. Okay, and u prime will just be the derivative of that, which is 4. So the derivative of the second natural log is going to be 1/2, and then times u prime, which is 4, over u, which is 4x minus 2. In this case, we can do a little bit of simplifying, right? We've got 2 and a 4 here, so that can cancel out and just get us a 2 up top. So I'd say this will be in its fully simplified form, 2x over x squared plus 3 minus 2 over 4x minus 2. And you do not have to get this into a single fraction. This is totally nice and fine how it is. Just leave it. All right, example number 2 of expanding and then differentiating. Here we've got the natural log of x squared, and then in parentheses times 3x cubed plus 2x, and that is raised to the 4th power. All right, so it looks like we have to expand this. Now inside we don't have a quotient, so I don't think we're gonna need anything with minuses, but we do have things multiplied. We've got this times that. So to expand this, these are both gonna get pluses because they're both up in the numerator. We're gonna get 2 separate natural logs. We'll get natural log of x squared plus natural log of 3x cubed plus 2x, all raised to the 4th. And once you do this, we basically did log law 1 and log law 2. So then you just want to look and see, are there any exponents you can take down? So we can bring the 4 in the front, we can bring the 2 in the front. So this will just be 2 natural log of x plus 4 natural log of 3x squared plus 2x. Now this is good. This isn't quite fully expanded, but it's good. We can definitely keep it here and then differentiate. Another option would be to factor out an x here and make it a little bit simpler. So I'm going to push us to do that. So let's factor out an x. I'm going to do this work over on the other side. So here, just this natural log. I'm going to write this as the natural log of x times 3x plus 2. So that we can then split this up into the natural log of x plus the natural log of 3x plus 2 because we have a product of, in there. Okay, so let's see, we've got 2 natural log of x, nothing's changing there. Then we have this 4 times the natural log of x plus the natural log of 3x plus 2. We're going to just distribute that 4 into the parentheses. And then here we've got 2 natural log of x plus 4 natural log of x. So we can just combine those together into 6 natural log of x. Again, it wouldn't be wrong to stop right here and differentiate this, but it's just, we can make it even simpler if we factor. So that's something to keep in mind. If you have a GCF or maybe a polynomial that you can factor, it can be easier if you do that. So now it looks like we're in a good place to differentiate. Don't forget to do that. I know you can get lost in the expanding and think we're done, but we haven't even found the derivative yet. But I think this one won't be too bad. So here we've got 6 natural log of x. Okay, so again, this 6 here is a constant multiple. So when you differentiate that, it stays there. It doesn't go to 0. It's a multiple, so it stays. And we're going to multiply that by the derivative of the natural log of x, which is 1 over x. And then again, we've got another constant multiple here of the 4. Now in here we have, some stuff that's not just not just x. So we have a u situation. So here we've got u equals 3x plus 2. Okay, then u prime will be 3. So when we find the derivative of the second natural log, we'll have 4 times u prime 3 over u, 3x plus 2. Now, one step of simplification is good, so we can just multiply 6 times 1 over x, that's 6 over x. And in the second set here, we've got 4 times 3 up top, so we can do 12 over 3x plus 2. And there we go, there's the derivative of that thing. It's kind of nice, these often, you get a few fractions and they tend to be simpler than, at least simpler than you would expect based on what we start with. Okay, let us look at this monstrosity here, the natural log of 1 minus x to the 4th times 3x minus 5 over the square root of 4 minus x squared. So here we do have a fraction. So I'm going to look up top and see what's all multiplied. So I've got this thing times this thing. So I've got two things. These are both going to get their own natural log and they're going to get a positive in the front of it. Again, we're thinking of expanding this first, then differentiating. So just expanding right now. In the bottom, we've just got one thing that's multiplied by stuff, just itself. So that'll have its own natural log, but it'll be subtracted. Okay, so if we're going to expand this first, we're going to have 3 natural logs. We're going to have positive natural log of 1 minus x to the 4th. We'll have plus the natural log of 3x minus 5. Then we'll have minus the natural log of the square root of 4 minus x squared. And remember, once you do this, the next thing you always want to do is look and see if there's powers that you can bring down in the front. So this could be 4 natural log of 1 minus x. No powers on the second natural log. But here we can bring down a 1/2 because the radical of the square root is the same as 1/2 power. Okay, so this looks we're in pretty good shape. 1 minus x, pretty simple. 3x minus 5, pretty simple. Optionally here, what we could do is split up this natural log by factoring the 4 minus x squared. So again, I'm going to do that, but it wouldn't be wrong to not do this. So let's see, let's just work with this here. I see 4 minus x squared and I'm just like, difference of 2 squares. I love factoring them. They're so nice. So you get 2 minus x, 2 plus x. Okay, so now we've got a product, which we can then split up into 2 natural logs by adding the natural log of each of the factors. Okay, the only thing we have to do is be considerate of this minus 1/2 that's in the front, because this is going to be multiplied by all of this stuff here. So let's be careful with that. So we'll say y equals 4 natural log of 1 minus x. Not doing anything with these two. Then I have minus 1/2 parentheses, natural log of 2 minus x plus the natural log of 2 plus x. Okay, last thing, I'll just distribute that negative 1/2. It'll just be negative 1/2 times the natural log of 2 minus x minus 1/2 times the natural log of 2 plus x. Now, I know this seems like a lot of work so far, but we did the hard part. We made it much simpler for ourselves. So if we're going to now differentiate, let's take it piece by piece. So in the first natural log, 4 natural log of 1 minus x, we have a constant multiple of 4. So that's going to stay and multiply. Okay, then we have inside, we have a u situation. So u equals 1 minus x And u prime will be careful here, -1. So this 4 is going to be multiplied by u prime over u, so -1 over 1 minus x. Then we will add the derivative of the second natural log. Here we have another u situation, so we need to see what's up with that. So we have u equals 3x minus 5, and u prime, the derivative of that will be 3. So we'll add u prime over u, so this will be 3 over 3x minus 5. Okay, then we'll subtract the derivative of 1/2 natural log of 2 minus x. Here we have a constant multiple. So this 1/2 is going to stay, so I'm just going to write it there. Natural log of 2 minus x, we've got a u situation again. So we've got u equals 2 minus x. So u prime will be, again, be careful here, -1. So we're going to multiply this 1/2 by u prime over u. So -1 over 2 minus x. Okay, last but not least, we've got one more, so we'll have minus another constant multiple of 1/2, so that's going to hang out in the front. 2 plus x inside, another u situation, so u will be 2 plus x. The derivative of that will just be +1. So in our last fraction here, we'll have 1 over 2 plus x. These are great. You've got like 4 problems in one, right? But it's just the same rule over and over again. So it's not too bad. So I don't know, a last thing here to just simplify, we might just put these together into a single fraction, but it's not that big of a deal. So I would just say this is -4 over 1 minus x plus 3 over 3x minus 5. This will end up being plus 1 over 2 parentheses 2 minus x and minus 1 over 2 parentheses 2 plus x. And there's our derivative. Okay, I've got one more example with, expanding and then differentiating, and it's another monstrosity. There's a lot of good stuff here. A very intimidating thing to find the derivative of. If I showed you this on the first day of class, and you would probably been very scared, maybe even dropped the class and ran away. We're going to find the derivative of this thing. So expanding using our rules is absolutely the key to this. Okay, so let's look at what we've got up top. So we've got x to the 3/4, we've got 2 to the x, and we've got this square root here. So these are going to be 3 separate natural logs with pluses. Okay, down bottom we've got this stuff times this stuff. So we've just got 2 natural logs that will have minuses in the front. Okay, so just in terms of purely expanding first, what is this going to be? So we'll have the natural log of x to the 3/4, okay, plus the natural log of 2 to the x, plus the natural log of the square root of x squared plus 1, minus the natural log of 4 minus 3x to the 5th, minus the natural log of e to the -3x. Okay, so once we have that, right, we took care of log law 1 and 2 all in one go. Now we want to look at the exponents. So this first natural log can be written as 3/4 natural log of x. This second natural log can be written as x natural log of 2. This third natural log, that radical or the square root, is 1/2 power, so we can bring that down in the front. This 5 can come down and multiply by the natural log of 4 minus 3x. And then we have natural log of e raised to a power. And remember the inverse properties say that those cancel out. And so what we have here is minus just -3x. That's nice, I like that. Okay, so quick scan here and just to see what's going on. So look inside of your natural logs. We've got x, very simple. 2, simple. X squared plus 1, can that factor at all? nope, sum of two squares cannot factor, so this is, as good as it's going to get. 4 minus 3x, that's good, and that's totally fine, not even a natural log there. So look, in 2 steps, we're actually in really good shape to find the derivative of this. So let's differentiate. Maybe something that we might do here is instead of minus negative 3x, maybe we'll just make that plus, right? Just plus 3x. Okay, so y prime. One piece at a time. 3/4 times the natural log of x. 3/4 is a constant multiple, so that's going to stay and multiply by the derivative of the natural log of x, which is 1 over x. Okay, then we will add the derivative of x times the natural log of 2. Now this one's kind of weird. This does not follow the same rules that we've been looking at with the natural log, because inside of the natural log here, you have a constant, right? The natural log of 2 is a number. So what we really have here, I'm going to use a purple, use a different color. So what we really have here is, it might be better to look at this as the natural log of 2 times x. Because what we have in the natural log of 2, again, is a constant multiple. Right, this is like 0.69 something, something, something. So if we're going to differentiate a number times x, like 3x, right, like 3x, what we get here is just 3, just the number. So when we differentiate the natural log of 2 times x, what we get here is just the number, natural log of 2. Okay, so the derivative of natural log of 2 times x will just be the natural log of 2. Now, if we were to differentiate this again, the natural log of 2 would be a constant, so its derivative would be 0. But we will not. We will not find second derivatives with natural log stuff. Okay, moving along here, we've got another constant multiple in the 1/2. Okay, so that's just going to stay. And let's see, we got to multiply by the derivative of the natural log of x squared plus 1. Here we have a u situation, right? U x squared plus 1. All right, so the derivative of that is going to be 2x. So the derivative of the whole natural log will be u prime over u. So 2x over x squared plus 1. Okay, almost there. We're going to subtract the derivative of the next natural log. We've got 5 here, which is another constant multiple. So that will stay, hang out. The derivative of the natural log of 4 minus 3x, we've got yet another u situation. So u will be 4 minus 3x. Okay, u prime, the derivative of that is, of course, negative 3. So then the derivative of the whole natural log piece here will be u prime over u, so negative 3 over 4 minus 3x. Last but not least, we've got to differentiate 3x, so we just get a plus 3 at the end of all of this. We did great here. We should probably take just one step in terms of simplifying. 3/4 times 1 over x is just 3 over 4x. Natural log of 2, that's good how it is. These 2's here can cancel out in the third part of our derivative. So we can just get x over x squared plus 1. Let's see, negative 5 times negative 3, that can just be plus 15 over 4 minus 3x, and then plus 3. Okay, again, no need whatsoever to put these together into a single fraction. It is wonderful how it is. We can just leave it.